The next method is the AC method, which is sometimes called grouping or split the middle term. So if you hear me saying those, it's the same thing. So the step one says find the product of AC. So again, the A and the C are the two numbers that we feel a little bit more confident on. We can see where they came from. It's the B that's a little bit hidden. And what I want you to do is find a pair of numbers whose product is AC and whose sum is B. Then you need to rewrite the polynomial with the middle term bx replaced with the sum of the two numbers found in step 2. Now that sounds like a mouthful, but you'll see what we're doing in a minute when we apply it to an example. And then lastly is factor by grouping. You already know how to factor by grouping, so this is just an extension of that. So if you actually like guess and check, you don't need to know this method whatsoever. If you've been doing great on guess and check, you can just watch this and see if you like it any better. But I would prefer that you use guess and check if you like it better. If guess and check is hard for you, then use AC method. So the first step was find A times C. So I take 12 times -5, which is -60. My B happens to be -17. Step 2 says I'm trying to find a pair of numbers whose product is AC and whose sum is B. So the factors of 60 are 1 times 60, 2 times 30, 3 times 20, 4 times 15, let's see, 5 times 12, 6 times 10, 7 doesn't work, 8 doesn't work, 9 doesn't work. Okay, so that's it. So those are all my factors of 60. Which two adds, or in this case, because we have different signs, we need one of each sign to add to -17. So this one's a bit tricky because 3 minus 20 is -17, but -5 and -12 add to -17. So you really need to identify if they're different signs or the same. Because they're different, it's going to be +3 and -20. -5 and -12 would work, but they both would have to be the same. So that's a little bit tricky, so be careful there. So I have 12x squared, and the middle term, what I'm going to do is I'm going to take these two numbers and I am going to split them up to be +3x and -20x. Just like when we distributed, remember when we distributed two binomials, we have 4 terms first before you combine like terms. So what I'm trying to do here is I'm trying to uncombine like terms with a very specific set of numbers so that grouping works. So next I'm going to take the first group and the second group and group them like I've done in the past. So the GCF of the first two is 3x, which gets me 4x plus 1. The GCF of the purple group here looks like -5, and that's 4x plus 1. So I have 4x plus 1 in both terms, so I have 4x plus 1, and then I have 3x minus 5. So this is the AC method. Some students find it very appealing because it's methods we've kind of used before. We've kind of used this two numbers that multiply yet add to, and they've also used grouping. But it does take 4 steps every single time. And when I put one student that uses guess and check racing another student that uses grouping, most of the time the guess and check student gets their answer faster. So if you can use guess and check, please use that. Otherwise, you can use this method. Now, if you notice, these are the same exact problems that I used for the other method, the guess and check method. So all of our answers are going to be the same. So you can go back and compare and see which one you like better. But I'm going to go ahead and finish these using the AC method. I multiply A times C, which gets me 8. And my B is 6. So I have the factors of 8, which are 1 and 8, and 2 and 4. It looks like +2 and +4 is going to add up to 6. So if I take that 6x squared and I break it up to 2x and 4x, the 1 just comes down and the 8x squared just comes down. Now I have 4 terms. I already know how to work 4 terms. On the green group, I'm going to factor out at 2x. On the purple group, I'm going to factor out, there's not really much to factor out here. In grouping, you're required to factor something out. So if you can't factor anything out, you need to put a 1. Are the two parentheses the same? They sure are. So I have 4x plus 1, and then I have 2x from the green group, plus 1 from the purple group, and that's my final answer. On the next problem, I take a times c. My AC, 6 times 7 is, in this case, negative 42. And I need two numbers that multiply to negative 42, yet add to 11. So that's 1 times 42, 2 times 21, 3 times 14, 4, no, 4 is not going to work, 5 is not going to work, 6 times 7, and 7 is already in my list. So of those, which group adds or subtracts to 11 when this is negative? So that means they're going to have different signs. So with different signs, it looks like 14 and 3 with the b being negative 11, the negative is going to go on the bigger number. So that's 6x squared. The negative 11x breaks up into b positive 3x minus 14x minus 7. With this AC method, the 3x and the negative 14x could technically be interchanged. It really doesn't matter what order you put it in. If you put it in one order and your neighbor puts it in a different order, you're both going to get the same answer, but your work will be slightly different. So go ahead and write it in the same way I'm doing it, so our work is going to be the same. Then I look at the two first terms, and that's the green group, so I factor a GCF of 3x. And the other group, we'll do it in red this time. It looks like I factor out a negative 7, which gives me 2x plus 1. Negative divided by negative is a positive, don't forget that. So my solution is 2x plus 1 and 3x minus 7. On the next problem, it looks like I have a GCF of negative 2. Don't forget we always factor negative out if there's a negative in the leading coefficient, which gets me 4x squared plus 5x minus 6. So once I have that, this is a little bit tricky in this method, the AC method, where we have 4 lines of work before our answer. So often students will forget that the negative 2 is going to be part of our answer. So what I'm going to do to avoid that is I am going to just drop the negative 2 down and have these little skeleton answers here at the bottom and do all my work on just this middle part, okay? And then when I get done, I can just slip it into the answer and I won't forget that negative 2. That's common with AC method students who choose AC method, is because they do so much work in between the first step and the last step that they forget the GCF. Alright, so my AC is going to be negative 24. So that's 1 times 24, 2 times 12, 3 times 8, 4 times 6. And I'm looking for two numbers that add with different numbers, different signs, I'm sorry, to add to 5. I think those two numbers are positive 8 because the 5 is positive, and negative. So this positive on the 5 goes with the bigger number, in this case is 8. So the 4x squared stays the same. Then I have negative 3x and positive 8x. Does it really matter the order? Not so much. I guess I'll go ahead and put positive 8x minus 3x. And then the minus 6 also comes down. Now I can group them. I have the green group, and we'll do a purple group here. So in the green group, it looks like I factor out a 4x. That's x plus 2. In the purple group, I can factor out a negative 3, and that's x plus a negative divided by negative is a positive 2. So that gets me x plus 2 and 4x minus 3. Now, good thing I wrote this negative 2 down here, because a lot of students will stop at this step and box it, and that would be wrong. Okay, don't do that. You need to remember to plug in your to bring down the negative 2, so I went ahead and wrote that in the beginning so that I could just slip my answer in there. Okay, so the next one has no GCF, but it does have those x's and y's in it. So we're going to go ahead and proceed with my AC method. So that gets me negative 40. I'm looking for numbers that multiply to negative 40 and add to 6. So that's 1 times 40, 2 times 20. 3 doesn't work. 4 times 10, 5 times 8, 6 doesn't work, 7 doesn't work, and 8's already in my list. So which two, let's see, we have different signs again. The reason we have different signs is because this is negative. Different signs, and I need to add to 6. That looks like a -4 and a +10. Now here is the mistake students will often make with this problem. We have 8x squared, and then positive 6x needs to break up into -4 and +10. But what students will do, because they see an x and the y, and this is a mistake, okay? They'll write 4x on one of them and 10y on the other. This is wrong. Do these two terms add up to be that term? Well, no, 4x, -4x plus 10y doesn't add up to anything because they're not like terms. So that's a common student mistake. What you should write is -4 with both x and y, because when you break them up, they have to be like terms, plus 10, again, xy, minus 5y squared. So you have to put the xy on both of them. So if I combine the two red terms, they truly would add up to 6xy. Next, I'm going to break these up into two groups. So that gets me what? 4x as a GCF, 2x minus 1y. On the purple group over here, I'm running out of room. That's a positive 5y, and that's 2x minus 1y. So I have 4x plus 5y and 2x minus 1y. The factors can be in either order. Okay, so on this last one, it looks like I have a GCF of 10, which gives me 6x to the 4 minus 1x squared minus 2. And to do my AC method, I take the 6 times the 2, which is -12. Don't forget that we're going to need to drop down the 10. Students who use the AC method will often forget the 10, so I'm going to go ahead and drop it right now before I even do anything, because there's so many steps in between the GCF and the answer that often students will mess that up. I'm looking for two numbers that will add to -1, and that looks like 4 and 3. A positive on the 3 and negative on the 4, because the -1 sign has to go with the bigger number. So the 6x to the 4 will come down, and so will the -2. In the middle, we have plus 3x squared and minus 4x squared. Again, they can go in either order. The work will be slightly different, but your answer will be the same. In the green group, it looks like I can factor out a 3x squared, which is 2x squared plus 1. In the blue group, it looks like I can factor in a -2, which leaves me with positive 2x squared plus 1, because a negative divided by negative is a positive. These two are the same, which gets me 2x squared plus 1, and then 3x squared minus 2. And that is my final answer.